Today we're programming a maze generator in C++. Hi, my name is Ghost. I'm a C and C++ programmer. This tutorial goes over some basic to intermediate concepts, but don't worry, I do keep things as simple as possible and I go line by line explaining every single thing in full detail. The highlight concepts that I go over is an algorithm called depth first search along with recursive backtracking. I also go over a little file input output, some basic object oriented programming, and even one lambda function. Well, let me stop rambling and show you how it works. Okay, so let's run the program. So here goes our menu. You can set dimensions, you can generate a new maze, you can display a maze, you can save maze, and you can load maze. We don't have anything saved yet and we don't have anything generated yet, so if I was to try to select number 3 to display the maze, then we'll see that there is nothing loaded or pre-made, so please generate a new maze. Now at this point there is a default dimension already set and you can just generate a new maze to see what that is, or you can set dimensions from scratch if you want to. We're just going to generate a new maze, so we'll select number 2. Okay, so we generated a new maze and it seems like it's like 15 by 9, I believe. So if we wanted to change the dimensions and generate a new maze, we can just set the dimensions by choosing input 1. You must use odd number only. Even will break everything, meaning like the border of the maze, and everything would just be misaligned, so this algorithm only accepts odd numbers for the dimensions. So we're going to choose something smaller. Let's set the width to 13 and then we'll set the height to 9. Now at this point, as soon as I input this last dimension, or I should say axis, it's going to automatically generate and display the maze for us. All right, so let's input, and there it is. There goes our 13 by 9 maze. Now the dimensions are set to 13 by 9, so I can keep generating a new maze over and over and over, and we will get a new maze, but within that dimension. If I choose to want to save this one, I can select number 4, can name it garden, and it has been saved successfully. If I go ahead and try to display, we'll see at the top it says viewing garden maze, meaning that it did save it. But if you want to double check, we can exit the program and come back in and see if it actually persists the data. So let's select number 6. Okay, let's run the program again. Okay, so once again, if I try to display the maze, nothing should be there. See, nothing was loaded, nothing was pre-made. So let's go ahead and load the maze. We called it garden. Okay, so it said that it successfully loaded it. So let's go ahead and try to display it. And there it is. So the data persists and we have our maze. Okay, so now you know how it works. Let's begin programming. First things first, what you need to know is that I exclusively program in VS Code and I build my own build scripts. With that said, I'll be using CMake along with MSVC to compile the program. There'll be a link to the GitHub repository in the description below. That way, if you need access to those build scripts, you're more than welcome to copy it from there. Anyways, let's begin. Okay, so we have a new project open and I'm just gonna go over some of the things that we have in our directory so far. So inside of here, we have this CPP properties. Briefly go over this real quick. The only thing that matters inside of here is this portion. What this does is that it allows our header files to be included in any CPP file without relative pathing. I'm going to show it on the screen so that way you can tell the difference. This right here is relative path, and then this right here is how it would look like without the relative path. This allows that. Okay, so moving on, we have our source directory, which is where all of our CPP files are going to go. We have the include directories where all of our header files are going to go. And then we have the CMake list, which I'll go over later on, which is going to allow us to build and compile our program. And then we just have these bat files, which allow us to simply just run the compile, which will compile it for us. And then this run just actually runs the application. But don't worry, I'll go over that a little bit later on and also include it in the repository. Okay, so the first file that we need is our main file, and we'll put that in the source directory. So main.cpp. I'm sure you know that this main file is the entry point for our program. Now remember, with your main files, you want to keep it as clean as possible. So we're going to take all of the driver logic and put it into its own file. So what that means is that we're going to have a file called driver, which is going to be our program file. And we're going to include it like this. Even though I didn't create it, I'm just going to include it here. And then our main entry here, int main. And the only thing we're going to do inside here is just say return run. Run will be a function that will exist in the driver class, or I should say file, not class. But this is all you need, so we can move on to the driver file. Okay, so next we're going to create our driver file. We're going to start with the header. We're going to put that in the include directory. The first thing that we're going to want to do is we're going to want to create a namespace to avoid any possible collisions. Even though this program is very small, we're still going to do that because we have some loose functions that are not going to be a part of a class. Anyways, we will name the namespace maze gen. Now for the driver, we only have 3 functions. We have one for clearing the screen, we have one for displaying the menu, and then we have the last one that will run the logic. So we're going to declare them here, and then we'll implement them in the CPP file. So first thing we're going to declare is the clear screen. Now these two are obvious, but the clear screen, what that's going to do is that's going to communicate directly with the terminal in a cross-platform manner, which I'll explain once we get there. And all it's going to do is just clear the screens, because this is a console app and we don't want to keep running down on the screen, so that way it doesn't scroll down. We want to just keep clearing it and print towards the top. That clear screen is going to handle that for us. Anyways, this is all we need for our header file, so let's move over to the translation unit. Okay, so we created our driver translation unit. And for those of you who don't understand what translation unit means, it's basically your .cpp file. But what it truly means is that it translates into machine code, because your compiler uses CPP files and only CPP files, not your header files, to take that and turn it into machine code, hence translation. And the unit part is the fact that it's just a file, so translation unit. Anyways, if you need more clarification, just let me know in the comments. So the first thing we want to include is the driver header. Next thing is IO stream, because we're going to be printing to the console. And then we're going to have this other file that we didn't make yet, but it's going to be called maze gen, which is going to have all of our logic to generate the maze. Nope, not max, it's maze. But we will comment this out because we didn't make it yet, and we'll come back to it. Okay, so remember we created our namespace here, the maze gen, so we have to do that inside of here as well. Okay, so the first function we're going to start with is the clear screen. So I'm going to copy this over into our translation unit. Now this one is very simple, but it does go over a preprocessor directive to make sure that we know what platform we're using. This preprocessor directive I'm going to use is very similar to a regular if statement. If you already know what I'm talking about, then good. If you don't, allow me to explain. Also, if you don't understand what a preprocessor directive is, it's basically some directive made for the compiler. So when it's compiling, compiler knows what to do at this certain point in the source code. So as I stated, it looks very similar to an if statement, but you begin with a hashtag and you're going to say if def, which basically stands for if defined. Now here we have this macro, which is a predefined macro. It goes underscore win 32, which that stands for Windows 32. So what we're doing here is we're checking that if this platform is in fact a Windows, then we're going to run the logic inside this if definition statement. And if it isn't, we're going to have this else here, much like an if statement, and we're going to run some other logic here. And now what you have to do, you have to close it out by ending it with hashtag and if. Okay, so to go over again, this is a preprocessor directive telling the compiler how to handle this function in this certain area. The if def Windows here means that if we're on a Windows, we're going to run some logic here. But if we're not on a Windows, let's say we're on a Mac or a Linux, we're going to run some logic here. And the reason why I needed this is because I'm going to communicate to the terminal using the function system. But for Windows, it's CLS to clear the screen, while on Macs or Linux, it's going to be the same thing, system, but it's going to be clear. Anyways, that's all we need for this function. So we'll close out of this and grab our next function from our header file. It's going to be this display menu. So we'll copy this. This is going to be another simple one. I'm actually going to copy it from my other file. Okay, so as I said, very simple. All we want to do is display the menu to the user. We're going to use cout, of course. But if this looks unfamiliar to you, and I'm referring to this literal right here, the R, all it allows you to do is to define how it's going to look on the screen. So by using this literal here, R, right before your double quotation, you have to also use this parentheses here and here at the end, but whatever you put in between will look exactly like this in terminal. So in this case, there will be a space because I moved to the next line. Maze generator will appear like that. And then there will be this little tab here. And then this down here, the choose an option will be like this all the way over. Okay, so I set up a tiny example to explain the difference here. So if I didn't use this right here, I'd have to do something like this where I have to use these characters for the line break and then this other character for tab. It's a little bit confusing because I had to input all these extra things inside here and it's still like on the same line. So this just looks cleaner and allows you to more accurately define how you want it to look like when it's printed. Anyways, that's it. So let's move on to the next function. So we will grab our run function. Okay, so this is where the core logic of the program will exist and will continue to exist until the user decides to exit the program. Okay, so the first thing that I want to do is clear screen because I want to make sure that there's nothing on the screen and we start fresh before we start printing anything. The next thing I want to do is declare and initialize our maze generator. Now, once again, we didn't create it, but I'm going to put it here and comment it out and we'll come back to it. Okay, next we have another stack variable that's going to be type int choice. And now that's going to be our variable for the choice that the user gives whenever they're selecting anything from the menu. We'll initialize it to -1 to start. Actually, I just caught something real quick. I need to change the return type to type int. I need to do the same thing in the header file because if you remember in our main function here, we have the run function like this, which whatever it returns, we return in the main. So that way we can handle anything that happens, like if we have to return a -1 because there was some error, or we just returned 0 because we're finished, we handle it just like that. Also, the reason why there's a semantics error there is because we didn't include the namespace. If you remember, we are using the maze gen namespace. So if I just copy and paste this inside of here, we can say using namespace maze gen, and the squiggly line is gone. Okay, so let's continue our run function. So the only other thing I'm going to add for now is the loop that's going to continue to loop over and over and over until the user decides they want to exit the program, which I believe is going to be number 6. So the loop we're going to use is do while loop because we want to make sure the loop at least runs once before we check the condition to decide if we're going to break or not. So we're going to use do while, and the condition here is going to say choice is not equal to 6. All we're saying is as long as the choice is not equal to 6 because the user does input something that is invalid, which we will handle inside this loop, or they choose something else from the menu like 1, 2, 3, 4, 5, then we will handle that. But if it is 6, then of course we will break the loop, and then here at the very end we would just return 0, which then goes back into our main translation unit here and then returns our main function. So we'll come back to this driver script once I finish the maze generator and also the maze strut. So I'm just going to leave this like this for now and let's move on. Okay, so the next file that we want to create is going to be our maze file, which is going to be our strut. First thing we need to include is our header guard, which actually I don't think I did in the driver one. Let me see. I didn't do that, so let me just include that there. Go back to your driver file, include that header guard. I'm not going to explain what that is. I'm assuming you understand. But if you do want to know what it is, you could ask me in the comments, but I'm just going to move on from that. So like I said, we're going to include our header guard, and then we're going to include vector and our string. Okay, so we're going to use that namespace again, and now we're going to define our strut. We're going to call it maze. Okay, the purpose of this strut is that it holds certain information about each individual maze that you're going to be creating, and some of that information is going to be like the width, the height, the actual grid where every individual cell is, like the walls and all the pathways. It's going to also hold the name of the maze, so that way we can handle the file input and output. And it's going to have two constructors, a default and a user defined one. So let's begin with the dimensions first. Now I prefix my variables that are classes or struts with the M for members. I know some people don't, some people do. I think it's considered standard when you are working in the industry, but it also depends on the company. I do it personally. You don't have to do it, but this is how I do it whenever I'm dealing with classes or strut members. Also, if you're unfamiliar with what I did here, you can declare multiple variables of the same type by just separating it with a comma instead of having to like that. It's just a shorter way of how to declare variables, so we can leave it like that. And now if you wanted to initialize them, it'll also work this way as well. All you have to do, that will still work, but I'm not going to initialize them in this case. I'm going to remove that. Anyways, that's just in case you didn't know. Okay, the next thing we need is a vector of character, and we're going to call this grid. Like I said earlier, this is going to be the grid where all of your maze data is going to be stored. And if this looks a little scary, the vector and then another vector in a vector, it's basically a matrix. For instance, if you don't know, let me just create an example. So if we had a normal vector of characters, how it's going to look like is that you're going to have, this is how it'll look like. But now in the case of this, where you have a vector that is holding vectors which hold characters, you're going to essentially have, what this states is that this right here, this bracket is this vector here, and this bracket here is all the vectors, the individual vectors, because remember, this is a vector of vectors, so there can be multiple vectors. So this is a bracket for this type, and then the characters, of course, are all the characters that exist in that vector. Now, I probably over explained that for some of the people who already understood it, but just in case if you didn't, that's all that this says. Okay, so let me remove all of that because we don't need that anymore. Now the next thing that we need is a default constructor. And if you didn't know, structs can actually have constructors much like classes, because essentially they are classes. Structs exist in C and classes don't exist in C, and that's how in the C programming language, how you're able to encapsulate members and have like an object oriented kind of programming, but not really. Anyways, I don't want to get off topic or explain that too much, but structs do allow you to create these constructors, default constructor, and then we're going to have this other constructor that will accept the two integers for the width and the height. Okay, now the next thing I want to go over is called member initializer list. If you don't know what that is, I can explain it in another video because I feel like it will take too long to explain exactly what's happening in the compiler. But what it essentially allows you to do is to assign these variables up here with whatever is passed in, or in this case, in the default one is to give default values to these members. But there is a specific reason to why you would use this, and like I said, I can go over it in another video. But anyways, it looks like this. You put a colon, and then you begin with the first member that appears in order. So we'll start with width. Since this is a default constructor, we're just going to give it some default value. We'll give it a 0. Next, we'll grab our height and we'll do the same exact thing. And then we actually forgot to include the name. So let's create that real quick. But now we'll include the name here, and the default will just be unnamed. Now notice it does look a little funny how we have our body, our brackets here, and there's nothing inside of there, but we're able to initialize these members here. That is the member initializer list. And it makes sense because it's members, it's an initializer because we are initializing, and it is a list because we're using a comma separated structure, so that's why it's called that. Anyways, moving on, at this point we're going to do the same exact thing as we did up here. The only difference is that we're going to assign this the width and the height. We're not going to assign the name, and I'll explain that when we get more further down the line, but we're going to assign the width and the height to this variable W and H. So we're just going to copy this, and then we're just going to change this to W and change this to an H. Besides that, we are done with our maze strut. Let's move on to the generator. Actually, I'm going to fix the name of the header file here. I use a capital M. I'm just going to keep it all lowercase. Make sure that you update that because it will error out when we're including it in our translation units later on. Okay, with that out the way, let's create the maze generator. So it would be maze gen, put our header guard up the top. First thing we're going to include is our maze strut. Next, we're going to include the IO stream. And last, we're going to include this other library that I'm not sure if you ever used it before, but it is called random. So we're going to be using this object right here, and that is included in the random library. What that is long story short, it's a random number generator. Okay, so moving on, what we need is this, the namespace. I'm just going to copy it because I'm not going to keep writing it over. Now this is going to be a class, and the name of that class is going to be maze generator. Now this file is a bit lengthy, but it is also the only file left besides going back to the driver. So I'm going to write out some of the things and then I'll explain it. Okay, so this is all of our class members. We have our private variables here. We also have this private function, and I like to create private twice here whenever I'm separating the variables from functions that are private or public. And then finally, we have our public functions here. So the first thing we have up here is our maze struct, and this will just hold the current maze that we're working on or that we generated. These integers here don't relate to the actual maze, but relate to the maze generator. Think of it as a canvas with the width and the height, and then the maze being constructed on top of it. The next member that we have here is the random number generator. Once again, I'm prefixing with the m underscore for all the members. Okay, this function here, carve maze, will be the algorithm that I was referring to earlier. This is a recursive function, so it will continuously be called over and over and over until it has carved out all the pathways in our maze. But don't worry, I'll go over that one more in depth later on when we get in the definition part. Okay, moving on here, we have our default constructor. We have other constructor that accepts 2 arguments for the width and the height. We have set dimensions, which allows you to set the dimensions of the maze generator canvas. You can think of it like that. It does also have this third argument here, which is a boolean, which will automatically generate as soon as you set the dimensions. I'll explain it more when we get there, but we set the default value to true, which if you didn't know you can do that, you could, but you can only do this in the header file, so don't do this in the translation unit. I'll show you when we get there. Next function here is the actual generate function, which will generate the maze. Basically construct a new maze, assign all the variables inside that maze, run this right here, the random generator, call the carve, basically do all of that inside this function. And then we have our display function, which will simply just display the maze on the screen. Lastly, we have our file input output functions. We have the save the file, and then we have the load from file. That's the end of our header file. Let's move on to the translation unit. Okay, so as I'm filming this tutorial, I got a really good question from somebody who saw the teaser to this tutorial that I put up on YouTube as a short, and I'm going to show the comment from this person right here. Deniz said, "Where is the entrance and exit?" And it's funny because it got me thinking, where is entrance and exit? I totally spaced out on that, and I decided to quickly develop an algorithm for that. So I'm going to add that into the header file right now. Okay, so let's go ahead and add that new function called entrance and exit. So we add that to the header file. Thanks again, Deniz, for that catch. Happy you did it, and I'm happy I caught it right at the moment that I'm actually filming this. So worked out really good. Thanks again for the comment. Okay, so in our translation unit for the maze gen, we have, of course, the header file for the maze gen. We have this vector, and we have the upstream, which is for our file operations. We have algorithm, which we're going to use a function called shuffle. I guess I'll explain that a little bit later on because it's not going to make sense right now. And then we have the S stream, which is going to allow us to create this buffer in the display function. So what I like to do, since I have private functions along with public functions, is to create some separators. So I'm gonna copy and paste this. Whatever is under here is going to be private, and then whatever is under here is going to be public. Okay, so let's start with the constructors first, starting with the default constructor. Now this is going to be real simple. Okay, so all we did was use that member initializer list, so that way we can initialize the width, height, as well as the random number generator. Now the width and the height we're setting to 0 because we're gonna do something in the generator later on that if it is 0, then we're gonna return early, because that means that it's invalid. We can't generate a maze based on a width of 0 or even negative numbers, you know, just in case if the user does input negative, but we're gonna default it to 0, so that way it's just invalid to begin with. And then the random number generator, we're just passing in this random device, which basically, as you see here, it's a class to generate random numbers. You just pass that inside of there. I believe that comes from this right here, this library, the random library. Anyways, moving on to the other constructor, which is going to be the constructor that we are going to use. So we are adding these parameters here, the width and height, and we're just substituting these default values for the width and the height. Okay, easy enough, so we can close out of that. Next, we're gonna grab this set dimensions function here. And now remember, I said you cannot have the default value in the translation unit, because then it will be a compiler error. To be more specific, a redefinition error. So we're just going to remove that from here. And then we need to add this, because we're referring to the class member set dimensions and not just some set dimensions loosely inside of this translation unit. Anyways, this function is going to be pretty simple. All we're going to do is want to set these class members here, the width and the height. But the problem is we don't want to accept any numbers that are even, because what will happen is the generator, it will be either misaligned, the border, the outer wall might be wrong, there might be actually some holes inside of it besides the entrance and exits. So it just works better if it's going to be an odd number. I'm not going to over explain why, but odd numbers would work best. So what we're going to do is we're going to set the width, but instead of just setting it to what the user passed and trusting that the user did pass an odd number, we're going to create this operator here, which I'm going to just write out and then I'll explain it. Okay, so what we are saying here, it probably looks a little crazy, but all we're saying here is that if the width divided by 2 is equal to 0, if you don't understand what that's doing, is basically trying to determine if it's an even number, because when you use this operator, which is the modulus operator, it's essentially the remainder operator. So if you divide any number, this number, the width in this case, by 2, and if it's 0, meaning no remainder, then it means that W must be an even number. But if it's an odd number, then there will be a remainder, so this will be false. So this is going to be our condition here to determine whether it's true or false, whether this is an even number or not. And the question mark here, so what I actually should say is that the whole setup here is called a turning operator, where basically you perform some conditional check here, and then the question mark is basically saying like, okay, whatever this is, true or false. If it's true, then we're going to run this here, and if it's not true, then we're going to run this here, or we're going to use that. So all we're doing is trying to set the width here to either this here or this here, and you separate which one it's going to be with this colon here. So altogether you have your condition here on this side of the question mark, and then on the other side of the question mark you have your 1 or 2 values that it's going to be based on what happens here if this is true. So in this case, if W divided by 2 is equal to 0 because there's no remainder, that means it's even. So then what we're going to do is we're going to choose this one, which essentially just takes that even number and increases it by 1, which make it odd. And we're going to set it to the width. If not, then that means that it's already an odd number. So we're just going to set the width to whatever the user did define. Long story short, this is a validator to ensure that the width is always set to an odd, even if the user attempts to set an even number. Anyways, we're going to do the same exact thing, but for the height. Okay, the last thing we're going to do in this function is check whether this boolean is actually true. So we'll check that in an if statement, and then if it is true, we're going to run the function generate. So now this set dimensions function comes from the menu here, which is number 1 in the menu. But as you can see here, the second one is generate new maze. So it's going to basically be up to the user if they want to set dimension and then automatically generate a new maze, or they just want to set the dimension and not generate a new maze. That is the point to the third argument. Okay, so the next one that we're going to grab is this generate function. All right, so the first thing that we want to check is to ensure that the width and the height is not equal to some negative number or 0. Remember up here in the default constructor, if it is used, then it will be 0, or a user can pass in a negative number when they're setting dimensions. So we'll say if width is less than or equal to 0, or the height, because it can be either or, so or the height is less than or equal to 0, then what we want to do is we want to return, because we don't want to continue, we don't want to generate, but we also want to display some message to let them know that they need to set the maze dimensions first, which is this function. Moving on, at this point we need to construct a new maze. Remember our maze strut inside of here, and if you look inside of here, we do have a class member that will hold the current maze. So we're going to grab this variable here, and all we're going to do is assign it to a new maze, and then we're going to pass in the width and the height. Now we don't have to worry about memory because this is all stack allocated. As we see here, we're not using a pointer, so nothing is getting assigned to the heap. And if you don't know what I'm talking about with heap or stack, I'm going to make another video in the future about it. But all it really means is where the memory exists. Heap just means that the memory exists longer. outside of like a scope. And then stack, it means that it lives within a specific scope, and we don't need it to be allocated on this heap here because everything's going to be inside of this loop here. It's going to be in that scope, so we don't have to really worry about that. And also, I should say, it's going to be assigned to this current maze, and the maze generator exists right here, so actually it belongs to this scope, the whole run scope. So it's going to stay on the stack, and we're not leaving this run function until we're done with the whole entire program. So it's fine for us to do it like this and not have to allocate the memory on the heap. And I say all this is because you can continue to generate new mazes over and over and over by inputting number 2 of the menu. So every time you do that, we're going to run this function, and we're going to reassign the current maze variable to this new object of maze, but we're not going to have some sort of like memory leak or anything like that, because like I said, it's on the stack. So once we replace it on the back end, the memory will properly get deleted because it's just on the stack. So it's just going to cease to exist. Moving on, the next thing that we need to do is take our random number generator variable. Remember, this is a class member, as you see right here. So we're going to take that and we're going to use the function seed. So the point to this function is that we need to generate a new seed every time we're generating a new maze, so that way we can get true randomness. So this is why we need to call this every time before we're going to call the other function, which I'll explain in a bit. So all we're going to pass to this is what we did up here, the random device. Next, we're going to access our maze, and then we're going to access the grid member of the maze. We're going to use the assign function. Now remember, the grid is a vector, and vectors do have an assign function. What we want to do here is that we want to fill the entire grid. We're going to use this character to fill up the entire grid. This is basically going to be our walls. So we're going to first fill up the entire grid with just these characters, and then we're going to use the carve maze function here to carve out paths out of this whole grid that will be filled first with this. Now remember, the grid is a matrix, meaning that it's a vector and a vector of characters. So in order to assign this, we need to first use the height, which is going to represent this right here, this part, the vectors. We need to assign this first, so we're going to grab it from the current maze. So current maze dot height, the first argument needs the new size, and as you can see there, it says new size, and then the second argument is going to be the values, and in this case the value is just going to be vectors. And then what we want to do is we want to then construct, that's where we're going to use the width portion. So we'll grab this, copy that, paste it here as a first argument, change that to width, and then that second argument here will be the walls. In this case, it's going to be the hashtag. Okay, so to go over the whole entire thing again, we're using the current maze, and we're using the grid member of that current maze, which remember is just this matrix here. We're using that, then the assign function of vector, which will allow us to resize the grid and then add some value to it. So we are resizing it based on the height that the user gave us as a first argument. And then for the second argument, we are creating these vectors of the characters now, which will configure as now going to be the columns. And then when you construct a vector, you can pass in the size of it, which is now going to be the width of the current maze. And then the second argument is the characters. I hope that makes sense. If you need any extra clarification, just please let me know in the comments. Okay, now lastly for this function, we're going to call 3 functions actually that are part of this class. The first one is going to be called carve maze, and we're just going to pass in 1 and 1. I will explain that. Second function is going to be the add entrance and exit, and then the last one is going to be display. So this function here, the carve maze, is going to be where the actual algorithm, that backtracking, that first search algorithm, basically what's going to happen is we're going to call this function here, and then inside of it is going to continue to recursively call it over and over and over as it draws out, or I should say in this case, carves out the path in this grid right here until it reaches the end. So that's why it's going to recursively keep calling it. And the reason why we pass in this 1 and 1 is because that's the first point. That's like basically going to be at the top left of the grid, and we're starting there every single time. This function here is going to take a look at the current maze and decide where it's going to add the entrance and exit. Now what I did was, the entrance is a fixed part, it'll always be at the top left I believe, but the exit will be random, but it will make sure that it is connected to a path. And the last function is pretty straightforward. We just want to display the maze once it is generated. Okay, so next we're going to grab the display function and define this one. Okay, so we have our display function in the translation unit. First thing I want to go over is this const keyword. You don't know what it is, it stands for constant, and we don't know why it's here is because basically what it states is that whatever is inside of scope or is inside this function cannot be changed. So if I was to take this and try to reassign to something else, this would error. You can see it here as it's saying that the expression must be a modifiable L value. I'm not gonna go over L values and R values and how that really works, but basically the reason why is because this const keyword is preventing it from being able to change. So it just protects any members from accidental changes. Okay, anyways, we will just delete this. And the first thing that we're gonna add is we want to make sure that the grid isn't empty. And if it is, we're gonna display some message and then return early because we're not gonna be able to display anything anyways. So I'm just gonna copy and paste this in. Okay, so that's in there and that's pretty straightforward. Next, this part is a little bit tricky if you don't understand buffers and how they work. Put it like this: we need to display the whole entire grid, and let's say if the grid is like 100 by 100, that means there's 100 times 100 characters. So that's quite a bit amount of characters. And if you think about how we have to display it, we're gonna have to loop through this whole entire matrix to get access to every single cell and then print it. So if we continue to call this cout over and over and over per iteration, it's going to cause some performance issues. So instead of just calling the cout over and over and over, we're going to assign whatever is at that cell to a buffer, and then once we're done with the whole entire loop, we'll print that whole entire buffer to cout. Long story short, it just provides a little bit of an optimization by using a buffer. So let me write it out and then I'll explain it. So what I'm using here is called a string stream, and all it really does is it allows us to insert these literals into the stream, much like as you would see with the cout, how you're inserting these literals into the cout. But the big difference is that it's not going to cout. It's not going to take that and display it to the terminal. It's just going to save it in this variable. So the first thing that we're doing here is taking this variable and we're inserting this here, just like you would have done it with cout. Next, we just iterate through that whole entire grid, and we have 2 loops to do that. We start with this first for loop, which is gonna go over our rows, or the height in this case. And then the next loop is just gonna go over the columns. I just have it labeled as cell. And all we're doing is just taking that, which is going to be the character at that point within our grid. We're taking that and then we're just inserting that into the stream. When we end that whole entire row, then all we're doing is inserting this line break here. And then when we're done with the whole entire grid, at the very, very end, once we have everything inserted into our string stream, then we just take that and then we insert it into cout, which will finally then display it. And we must use this dot string function here because it's not a string yet, it is a string stream. So you have to convert it into a string, and that's what the function of this class does. But yeah, that's it. It's pretty straightforward. We are done with the display. Let's continue. I decided to copy and paste it from my actual project file, which will be the GitHub repository. It should already be down below in the description. But anyways, I decided to copy and paste it directly inside of here, along with the comments. It'll be a little bit easier to follow along, I felt, if I do it this way. But let's start. So if you recall, this is the carve maze function, which is found inside the generate function here. At this point, remember I said that we call that and then we begin the recursion in order to carve out the path within this grid that should be full of this character right here. Actually, let me just show you, like, so you can visually understand how that would look like. So yeah, at this point, let's say if you call it generate and then you're here where we already set the width and the height, and let's say in this case it's a 5x5 grid. That's what the user defined at some point. What's going to happen at this point, what this grid is going to look like, it's going to look like this here. And basically what you see is the whole entire maze has nothing but walls at every single cell. What's going to happen when we call this carve is that it's going to use this random number generator seed along with the function inside of this carve maze to decide where it's going to create pathways, starting at this point up here and carving its way all the way down to the end of the maze. Anyway, so going back up into the carve function, so where we're going to begin is with these stack variables here. Now notice that each one of these variables is declared as static, and to briefly go over what static is, it just means that these variables belong to the actual function and no particular instance of that function. To try to break that down is that every time I call this function, this could mean something else that it doesn't mean right now. So for instance, this variable here, it's going to change constantly within this function here for the shuffle, which comes from, remember, the algorithm. This is going to take these numbers here, 0, 1, 2, 3, and shuffle them. So the next time that this is called, especially it's going to be recursively, it's not going to be in this order like you would normally think whenever you call a function that has stack of variables inside of it, is because they're labeled as static, meaning that the memory is going to persist even long after you're out of this scope. I hope that makes sense. I will have a video in the future going over what static is in these different contexts and in this particular context of a function, but I don't want to get too hung up on too much of the technical details. Anyways, to go over what these variables are for. So the dx and the dy, they're just basically positional variables. So for instance, the dx up here, it moves left or right, and that's what these are for, and it does it in units of 2. And then we have our dy, which is the opposite. This is our up and down. These are our movement offsets, that how we're going to move through the grid and decide where to place a path, and we're doing so by units of 2. And that's why we needed to make sure that our width and our height are going to be an odd number, because we're doing it for the structure and the alignment of the maze, if that makes sense. Okay, moving on. So this part here is going to be our list of directions, deciding on which direction we're going to take. So these are indices for these arrays up here, deciding on which movement we're going to go with, and these are constantly shuffled, allowing this to be more random. And that's the point to this function here. And all this does is it takes this vector starting at the beginning to the end and uses the random number generator to decide on how it's going to shuffle it over and over every time the carve maze is called. It's not going to look like this. So maybe one time it looks like this, and then another time it switched up again and it looks like something else. Anyways, moving on. So at this point, what we're doing is we're setting the current open path based on what was passed here. So initially, remember, we passed in the 1 in 1, so that's at that top left position. So we're just stating that that's going to be an open path, and then every recursive call after, when this x and y updates, we're going to make that another open path. So that's all that that's going to do. This right here is a lambda function, and if you don't know what a lambda function is that it's a function but an anonymous function, meaning that it doesn't have like a regular signature like you would think with like this function here. You can just assign it to some variable, but this portion right here is considered the function, meaning that it's anonymous. It doesn't have a identifier, but you can assign it to some variable like I did here. What it does is it allows us to create a function within a function, and what this function does is going to determine the bounds, because we don't want to create any open pathways if we're on the outer edge of the maze or beyond it. So we have to know where the bounds is, and that's essentially what this does. The AX just stands for the axis, the current axis, which we can be on the X or the Y. And the bound is just going to tell us whether it's the width or the height, whether in this case, if the axis is greater than 0 or if it's less than bound minus 1. So basically, if this whole entire statement is true, then we are in bounds. Okay, moving on. I hope you're still with me. Next up, we have this loop. And basically what it does is what you see here, it iterates through these shuffled directions. So remember, these directions up here, they will continuously be shuffled. So it iterates through that. So then using each direction, starting with the first direction here, we're going to, and it doesn't mean that 0, it could be anything because remember it's shuffled. We're going to use that to then access these arrays up here, like I stated earlier, and use these directions as indices for these arrays, use that and add that to the current X that we passed in, and then that's going to be our new X, or in this case NX. And then we do the same exact thing with the Y, because what we're trying to do at this point is we're trying to get the new position, decide on which direction we're going to go from the current cell that we're at. Okay, now at this point we're going to use that lambda function. Remember, it's right here. So we're going to use that lambda function and we're going to pass in the nx and the ny along with the height. So in this case, the ny, which represents the height. So we're going to pass in both those variables there to determine if we are still in bounds. And if it is, then we move on to the next one, which we're just checking the x. And if those two are true, then we just move on to this last portion, which just simply states that we're at a point that it's a wall, and because we want to convert that into a pathway. So if it wasn't, then we want to skip over that. Okay, so moving on, it's a little bit of math, so I'm going to kind of brush by this a bit, but all we're really doing is what it states here, we're carving up hashes by opening the wall between the current cell, which remember is just the y and the x. That's our current cell that we passed in as arguments. And then the new cell, which is the y, the x, which we're getting from this up here. Remember, these are our movements, and we're using the direction in order to get the new cell, and then we're just dividing by 2, and that's the position that we're going at in the grid, starting with the row here, and then the column, and then we're assigning it to that open character. I hope that makes sense. I didn't want to over explain the math part. Lastly, this is the recursive part. We're going to call the carved maze again, but this time we're going to pass in the nx and the yx as you see up here, because that's our new position. So we're going to pass that into there and then keep going eventually until we go from the top left corner all the way down. And once we reach the end portion and there's nothing left, so pretty much what would happen is this will fail, then we'll begin to start to return back up the stack until we're all the way back here, and then continue on to add entrance and exit, which is what we're going to implement next. Okay, so once again, I just copied and pasted the function inside of here, and then I'm just going to go over it little by little. Anyway, so the point of this function is to add an entrance and exit, because at this point we now have a carved maze, meaning that on the border of the maze we have a complete wall, so there are no entrance or exits yet, and then inside it is completely carved out, and then all we need to do is add that entrance and exit, so that way we can complete the maze. So how we do this is that we do it in 3 steps. The first step is to figure out the entrance. Now in this case, as I stated earlier, the entrance is going to be a fixed position, so all we're really doing is iterating through each column, and that's why we're using the width in this case. Starting with x equaling 1, and the reason why it's 1 is because we're not going to go on the actual border part, so we have to just go +1, and we're going to skip by 2 because remember that is how we're moving. If we're inside here, the carved maze, we're moving by unit of 2, so we're skipping 2 each time we move forward. So the whole point is to find a valid pathway, so that way we can add the entrance to that, because we don't want to add an entrance to a point where there's a wall right there. So what we are doing is we're going to that second row and we're iterating through that row by 2s to find a pathway, and if we find a pathway, what it says right here, then we can go up to that first row, which is the border, and add that entrance, which is what we will do right here. And then once we do that, we just break early because we don't need to do anything else. Okay, so then once we have our entrance, then we need to find all possible exits, because unlike the entrance, the exit could be random. So we just need to first find all the possible exit locations, and then we'll move on to this part here, which will pick a random exit from all the possible locations. So we are essentially doing the same thing that we did up here, but just now on the bottom part, because the entrance will be on the bottom still. So like the top here, we iterate through the columns, skipping by unit of 2, and then we're going to determine here, going at the bottom, remember that's why we use the height and then subtract by 2 to get like right on the bottom. We're going to determine that if that is an open space, meaning that there is a pathway, we're going to just push that back into this right here, the valid exits, which is going to hold all of the indexes of possible exit. When we complete the entire row, meaning that we get through all the columns and then add all of our possible valid exit points, we're going to exit the loop, and then we're going to reach this part here. As long as it is not empty, all we're going to do is go into our vector and then use our random number generator and divide that by the size of all the valid exits that I did find, but we're going to use the remainder of that as the index to get that specific index for that exit point, follow me, and use that to be the open exit. I hope that makes sense. So in short, all we're doing for the exits is trying to find all the valid exit points based on if there's a pathway or not, and then we're just trying to randomly select which one we're going to use, and then on the bottom assign that exit point. Okay, so all the hard and complicated stuff is out the way, because between carve maze and addEntranceAndExit, those are the more like complicated algorithms for this program. The next thing that we have to do is implement the save to file and the load from file. These are pretty straightforward, and I'm not sure if you have any experience with file input and output, so I will go through that line by line, but I think I'm just going to copy and paste things over just for the sake of time. Okay, so starting with the save to file function, we are back in our translation unit and we just copied everything over to here. So I guess I'll begin with the parameter and briefly go over that. So we are using a const string reference for the file name, and the reason why it's constant is because we don't want to accidentally change it inside of here. And the reason why it's a reference is because we don't want to make unnecessary copies, so we just pass it as a reference. The first thing we're going to do here is that we're going to assign that name that we gave the file to the maze name. Basically, if you remember, we have a name variable inside the maze struct, so we're just assigning that with the file name that the user defined. Okay, next we need to open up the file that we're going to be saving to, and we're going to use the OF stream, which stands for output file stream, which comes from this F stream library. How you construct this is that you use the object and then you give it a name, and usually we just call it file because that's what it is, it's a file. And now for the arguments of the constructor, the first thing that we're gonna pass is the file name. Now for the second argument, that's the mode that we're trying to open this file in. And in this case, we're gonna open it in binary because I decided that I wanna save it that way instead of being able to see it as a text base. Okay, so next we're gonna check and make sure that the file did open, because if the file is not open, then what we wanna do is we wanna tell the user that, hey, there was an error saving the file, and then return early because we don't wanna do anything. That's pretty simple, so I'm just gonna move on from that. The next thing that we wanna do is determine the length of the name that we assign into the current maze. These next parts are gonna be a little bit more advanced, I guess, is because we are using binary, so maybe I probably shouldn't have used binary, but I'm gonna briefly go over it so that way you just get exposed to it if you never used it before and you don't really understand what none of this means. But it's just to say that the data that we're going to be saving, instead of just saving the maze as the hashtags, instead of saving it as that and you'll be able to open it in the file outside this program, it's going to save as binary data. So when you try to open it, for one, it's not going to let you unless you have like a hex viewer or something like that. So in order to save the data, you can't save it like the other ways that you may be familiar with. Like for instance, if I was to use file and then use the insert and then take this, the name right here, right? If like you try to do it like that, then all that's going to do is just insert that name to the top of the file, and then I can just keep inserting other things. But that's not what I want to do because we're working with binary. So you need to do a couple of these other steps first. And some of the data that we need to save in this case is the name length. So that's what we're grabbing from this string, is just the size, and then saving it here. And then next, what we're going to do is we're going to utilize the write function, which is part of the file object, instead of using insertion, because remember, insertion is mainly meant for text, and since we're using binary, we have to use the write function. So the first thing that we're saving is the name length, and we're doing that here at the top. Here we're saving the actual data, the string value. Next, we're going to save the width and the height, so it's very similar. And we have to use reinterpret cast instead of something like static cast, and then we wouldn't use dynamic cast because this isn't heap anyways. But we have to use reinterpret cast. If you've ever used casting before, and if you didn't, all it really does is just specify that this here, that's why we're using the ampersand, because we're getting the address of, so that this here is a pointer, and that's how we need to pass it into the right, because that's what it accepts. Now lastly here, something that looks a little more familiar is that we're just going to loop through our grid, and then we're going to take that data, so the row data and the row size, and we're just going to continue to write all that data to file. Now notice we didn't have to loop twice to get through the rows and get through the columns, because we're not doing it by text, we're doing it by binary. So we can just take the row data and then just get the actual data part in binary and put that inside there. And then the second argument is of course the size of the data, and then that's what we send to the write function. Okay, now moving on to the load from file. A quick rundown is pretty much almost like reverse to the save to file. But what we're going to do is, instead of using the OF stream, we're going to use the IF stream. Do the same thing, pass in the name, open it up in binary. We're going to check this, but we're actually going to use the function is open. And if it's not open, error out, and return false, because the return type is going to be Boolean, so that way we know if we're able to load from file or not. And then moving on, as I said, we're just going to reverse everything. So as you see the name length here, we're going to use the read function to get the name length, because remember, that's what we put first, and that's the structure. So we're going to first read that. So at this point, we're going to actually use that information to resize the name. Next, we read that value, and then we assign it to this string up here. Moving on, we load the width and the height. Do the same thing here using the reinterpret to cast it correctly to the type chart pointer. And then we use that information about the width and height that we loaded to assign the grid, which is what we're doing here. And then finally, we loop through the rest of the data in the file, and we just read in the rows and we assign everything to the grid. And the last thing that we do is we want to update the generators width and dimension. So remember, this is not a part of the current maze. This width and height is a part of the actual generator. And then you let the user know that the maze loaded successfully, return true because we are successful. Okay, so we are all finished with the maze generator. So let's go back to the driver script. All right, so since we have the maze generator completed, we could uncomment this and uncomment this one. Now, if you remember, the maze generator has two constructors. So we're using the constructor, we're passing in some data for the width and the height. We could have just omitted this and then we would use the default, but remember, the default initializes 0 for the width and the height, and that technically will be invalid when we try to generate here. As you see, we must set the dimensions first. So it's possible you can use that, it's okay, but then like if you try to generate, it'll just give you that message. So what I decided to do is just use the other constructor, which will just pass in the width and the height. Now let's say if you just didn't want to have that default constructor, then what I technically could have done in the header file is to just set this to delete. And what that does is it just pretty much removes the default constructor completely and forces the user to have to use this constructor. If I also go back and say here, if I try to do this, it'll give us this error because it doesn't exist. See, the default constructor of the maze generator cannot be referenced because it was a deleted function. So we could do that too, but we're not going to do that. We're just going to leave it as is. So we'll bring that back. and we will bring that back too. Okay, so the first thing we want to do in the loop is to display the menu. Next, we want to get input. So we're just going to use the standard library cn and then use the choice that we have up here. So that's just going to prompt the display along with that choose an option here, and we're not going to line break because we're going to want to give the input right on that line. And next, we're actually going to call clear screen again, because what we want to do is we want to display the menu and then prompt right here for that input. After that user gives the input, then we want to remove the menu, so that way we could begin to display any responses based on what the user chose, basically just making it cleaner on the screen. Okay, so now what we want to do is we want to validate this input, because it is possible for the user to input something that is non-numeric, like a letter or symbol, and that will cause a huge problem with the input buffer, where basically on the next cycle it'll still be left over in the buffer, and then it'll go through this weird undefined behavior. So we need to handle any cases. So how you do that is that you need to check the cn flag. Now there is a function in the cn object called failed, returns like a boolean to say whether it failed or not. So we say cn.fail. And now the reason why that flag will be tripped is because a letter cannot go into a type integer, or a symbol can't go into type integer. Technically it can, but it'll like convert it to numerical. But in this case, when you're using it with cn, it is technically an error, because it's going to try to assign that letter to type integer, and it'll know that it's just not an actual number. So then it will raise this flag and cause an issue. So once we're at this point, then we want to handle clearing that input buffer and fixing everything, and then letting the user know what the issue was before cycling back on the next iteration. So the first thing we need to do is clear the flag, because if we don't, then it's going to continue to be in this fail state. So we're going to say std cn.clear. That will clear the flag for us. And now the next thing that we want to do is we're going to call this ignore function, which is part of cn again. What it does is it's going to ignore anything that is left in the buffer up to some specified character, which in this case is going to be the enter character, because technically that is all the way up to the last thing that the user had input in order to pass this point right here. So we're going to say std cn ignore. Now the first argument is the stream size, as you see here. So we don't know how much input the user gave. So the best way how to handle this is just to use the std numeric limits string size, and then there is a function called max, because we just don't know. So we'd rather just get the max stream size just to be on the safe side. Okay, and then the second argument is going to be that character that we want to read up to and then ignore. So that's going to be the enter. Okay, so the next thing that we want to do is let the user know like what happened. So we're just going to print this out: numeric input only, letters and symbols not allowed. Last thing we want to do is to use the continue keyword, because we don't want to continue with this iteration. We're just going to move on to the next iteration. And actually it's probably best to move this validation up here, because we are using this continue anyways. And I think my train of thought before was if we weren't using this continue and we actually kept going and we didn't skip this iteration, what would happen is that this, like, so if this whole entire thing, let's say, let's just show it real quick. So if this was up here, but then we got rid of the continue, what would happen is we would print this out, but then we'll clear screen right after, and the user wouldn't know what happened, because this would print but then quickly clear. So I think that's why I dropped it below. But technically now using the continue, we're just skipping this iteration, so we never go beyond here. We just go to the next iteration, just switch it out and drop and put this up on top of the clear function. Okay, so the next thing we're gonna do is just look and see what choice the user gave and then handle that branch based on that. Now, some people may use if statements, but that would be a bad idea in this case, especially since we're using integers, which is going to be a lot easier. So what we are going to use is called a switch statement, and I'm gonna write it out real quick, and then I'll explain why you shouldn't use an if statement. Okay, so the switch statement looks like this, where you have this switch keyword, and then inside here is the expression, but in this case, all we need to do is pass in the choice variable here. And then based on this choice, we just look at the case. So if this choice happens to be a 1, so the user input 1, which is a valid choice up here, we're gonna have valid choices all the way up to 6. So if the user input 1, then what happens is we're gonna go into this case and run some specific logic. We can keep going and add other cases, which are gonna be the 1, the 2, and the 3, which we'll continue in a little bit. So if you have this if statement like this on the worst case, meaning all the way at this bracket here, you're gonna have to, or I should say the compiler is gonna have to evaluate every single one of these conditions here until it reaches the end, which basically wastes a bunch of instructions, just trying to figure out what branch to take. Now, switch statements don't do that. They go directly to the case based on this variable. So if it was the worst case, and this case would be default is pretty much like the else case down here. If it was the worst case, it'll jump over all of this and doesn't even care about it. It'll just jump over it and go right to this block and run whatever logic is inside of here. So to wrap it up, switch cases are much faster than if statements when you're thinking about the worst case scenario. Okay, so case number 1 is the set dimensions. So what we need to do is we need to prompt the user for the width and the height. So what we need to do is create 2 variables, which will be of type int, the width and the height. But there's going to be a problem here, and right now it's not showing it, but there is a problem. You can't create variables inside of these cases right here because it isn't considered a scope. So a simple solution is just to add a scope. So you do that by just placing brackets inside of here, move this into the brackets or into the scope, and you won't have any issues. Okay, next, all you're gonna do is just prompt the user. You're gonna display some message, and then the user is going to input the value. So we're just gonna copy and paste this real quick. Now that we have these prompts here, I actually noticed that I didn't handle this before, but there will be another issue again, or a possible issue, is because we're not validating these inputs, right? Like we did up here, we validated. So what we could do is we can wrap this in a lambda. Actually, we're not going to use a lambda. We're going to use an inline function because it'll be better, and I'll explain why in a little bit. Let me just make it and then now explain why. Okay, so what I did was create an inline function called validate input. If you don't know what an inline function is that it is not like a real function in a sense of it creates this real signature in memory. Let me give you an example so that way you can understand it a little bit better. So I have this down here just like this, right? Minus, don't worry about the continue part, but I have this like this, right? So what this does is that every time this is called, so if I was to replace this with this, but all it really does is takes everything inside of here and puts it here. That's all it does. So every time I call it, which I'm going to call it here as well, and I'll call it here as well, but all it's really going to do is take this minus, don't worry about the continue part. It's going to take this and just place it here and here. That's all it's going to do. So now you may think, okay, well, that's just going to bloat the code out. And in this case, in this very specific case, it's okay to use it because it isn't that crazy what I'm doing. If you had like a really big function doing a lot of different things like computation and whatnot, and you label it an inline function and then you call it in multiple places, that will be bad because that will definitely blow out the code. We're gonna get rid of this and call it like that. Now instead of me having to build up the scope like this, I'm just going to remove it to make it just a little bit cleaner and put it all on one line, and that should be fine. So now I can put this in these places and it should be fine. Number 2 is very easy. All you're going to do is print some message out saying that you're going to generate the maze, and then you're simply just going to use a generator and call the generate function. Move on to number 3. This one's super easy. I'm just going to copy this, paste it here, and change this to display. Next, case number 4. That one is, okay, we're gonna save. So We know we need to prompt the user for some information, so we're going to create a scope. I'm going to copy and paste this because it's pretty straightforward. So we create a string called file name. We display some message to the user to prompt them to enter a file name, and then we insert it into this file name variable, and then we pass that to the save to file. Okay, number 5 is very similar. It's a load maze. It's very similar to number 4. You have the file name, you prompt the user to enter a file name to load, you get that input, and then you call the load from file. But in this case, remember, this is a Boolean return type, so if there was an issue, all we're gonna do is just print this to the screen. The last case, case 6, is the exit case. And all we're gonna do is just display a message saying that we're exiting the program. Okay, for the default case, that just means that the user inputs something that was a valid number, so we bypass the validate input here, but it just wasn't any of these cases here. So it could have been a negative number, or it could have been something higher than a 6. So what we just need to say is this is an invalid choice, so try again, and then it will loop back up and run the whole logic again. Now, if the user did select case 6, it will display that message there, but then when we read this condition here, it will become false because choice is in fact equal to number 6. So then it will exit, reach here, and then, you know, return back to the main, and that's it. We're done. Now, one thing I wanted to discuss really quick is that there will be an issue if the user gives a file name that has a white space in between. So like, you know, let's say something like the user inputs garden world, I have no idea, but let's say the user inputs something like that has that white space. Technically what would happen is, since we're using CN and then we're inserting into file name, what CN does is that it reads all the way up to either the enter, or it'll read all the way up to a white space, in this case here. So what would happen is file name will become garden, and then the rest here, the world, will be left in the buffer. So another method that we can use is use the get line, and I just got to make sure that what we need is the string, because inside of this library, the string, we have access to that get line function. So then we'll come back down here and we'll use the get line. You have to pass in the CN as a first argument, and for second argument, you're just going to pass in the variable in which you're trying to save to. And then we'll just get rid of this, and then we'll do the same thing for this load one here. We're done with the program, so let's just move into compile testing, and then we'll handle any possible situation. All right, so in order to compile this program, I have these files here, which I stated in the beginning of the video. I'm using CMake, and then I have these batch files right here, which is going to help me compile and run without having to write all this out or whatever. So for you, if you want to compile, I'm not going to go over these line by line. You can go into the repository. Once again, it's in the link in the description, and you can download the whole entire source and then grab just these files here. Now, this is if you're on Windows, because batch files do not work on Mac or Linux. I'm going to have a shell script file as well, which is going to be basically the equivalent of these. I'll have it in the repository, so don't worry. So if you're on Mac or Linux, use that version. So you can build in debug or release mode. In this case, we're going to build in debug. If everything is good, it'll work all the way through, all the way to the end with no errors, no red marks, right? Let's hope. Perfect. But in my defense, I obviously already wrote this whole entire program before, and I pretty much copied and pasted everything, so that's why it worked. Good. Anyways, whatever, it worked. So let's test it out and make sure that it actually works, right? And with that, we're gonna use this run batch file. So we're gonna do the same exact thing we did with the compile batch file, meaning that we have to input whatever build it is. So I'm just going to run this clear, and then we're just going to say .run debug. All right, so here goes the program. Actually, before I show you, we test this out, I'm just going to show you what happened, like how it generated and where are the build files. So it generated this bin directory and this output directory. So the bin directory was where all the actual binaries are, And if we were to create a release mode inside of here, so you can see the debug mode, but if there was a release mode, it'll also be in this bin as well. This output directory is where the actual executable is, where you see here the maze.gen.exe. So I just want to show you real quick what happens and where it's generated. And also, by the way, in this out directory where the executable is, that is where we're going to save any mazes that we save here. It's going to save in that directory. Anyways, let's just test it out. Let's try to display it. Okay, so yep, that's expected that there is nothing loaded or pre-made, so we must either load or pre-made. And since we don't have anything saved, we must generate. But let's just try to load and see what happens, because I don't even think I tested this before. So, okay, so perfect, here goes an issue. So it's like I thought what would happen, to enter a file name, but an error loaded file, blah, blah. So what happened is it relates to how we're getting that input at that line. So we're gonna have to close out of here and fix that. Okay, so yeah, it works. What I did was I just simply put this right here to ignore the anything that was possibly left over in the buffer. When you flip-flop between this stdcn and then the actual get line right here, there's an issue there where sometimes things are left over in the buffer, so you need to clear it out. I just threw it here for now. I'm not gonna like make it all neat and optimize it and do this and that. I'm not doing that right now. We're just trying to figure it out. So to update your code, go down to case 4. And all you're gonna do is you can copy and paste it. So come up here to the validate input, grab this line here. You're gonna paste it right under the get line. Also inside of here, since you're essentially doing the same thing. Anyways, let's continue to test. So we're in the load portion. So let's just give up some bogus name that I know does not exist. So bogus, cool. So error loading the maze file may not exist. Failed to load maze, try again. So that worked. So if I try to display the maze, you click that, we'll still get that message that there's nothing loaded. We attempted to load something, but it didn't exist. So there's still nothing loaded and we still didn't generate a new maze. So let's just generate a new maze and then go from there, right? And there we go, we generated a maze. Now remember, what we did was we passed in some values for the canvas, right? The width and the height, so it's 15 by 9. And that's what we're seeing here is a 15 by 9. Also, hey Dennis, notice the entrance and the exit. Thanks for that comment once again. I'm happy that you caught me right as I was filming, because it's perfect that I was able to implement it. So thank you so much for your comment. If I now generate again, this entrance will remain in the same place, but the exit will change. So let's generate. Okay, bad example. Generate again. There we go. Okay, now it changed. So, okay, let's say if I want to save that one. Now, if I want to display that one, even though it is displaying, but if I actually input number 3 to display, it'll just display it again because it is currently assigned to this current maze. So we have it in memory. Remember, stack memory, not heap. So it is there. That's why we can click display and it'll just continue to display again. But notice we're seeing that it's saying viewing unnamed because it wasn't saved. So now if we go to save it, garden, and to test out that white space, we're gonna call it garden world. Why not? Let's just go with the joke still. Let's hit enter and oh no, error saving the maze. Why? Let's just make sure that we're still viewing it. Okay, so it's still there. Okay, that was a little bit of a tricky bug, but yeah, I totally spaced out on this. So remember how I said to put this down here? Well, where you put it matters, and I just happened to put it in the wrong place. So remember that whole thing where you flip-flop between the CN and you go to get line. Well, it matters when you're going from CN to get line and not from get line the other way. So we had it right below get line, so just take it. So go back to case 4, take it and move it up above get line, so that way it clears any potential issues in the buffer that may have arise from CN. I think the reason why actually is because, now this gets a little technical, so the CN, what's happening is is that it's taking, let's say if you chose number 1, it's taking that value, putting it inside choice, but it's completely leaving the enter, it's leaving this character, which is because you hit enter to submit that input, it's leaving that inside the buffer. And now that's an issue because when you come down to the get line portion, which is case 4, and if you don't like clear that from here, what's going to happen is it's going to assume that you just hit enter again. So then it just jumps and goes, and then what was happening is our file name was completely empty, and so then that was failing the save because it's completely empty, so we can't open a file if you're not even passing a name to it. So it just created this domino effect of errors, and that's the issue when you deal with the input buffer. Fun times. So long story short, just put this on top of the get line and you should be fine. And remember, update case 5. So we're going to remove this from here and put it up here because you will just have the same issue. And that's it. We're good. So let's continue. Okay, so trying to pick up where I left off, let's just generate a new one. I'm going to generate a good one. Okay, so let's save it. This time it's going to be saved. Garden World, we got this. This is the one. I'm gonna put exclamation point on top of it because this is the one. Boom, maze saved to Garden World, which is the actual file name, successfully. So if I was to view it, we can just view it again and it works, but let's just make sure that the data persists. So we're going to exit the program and then we're going to re-enter it. Garden World, exclamation point, entered, yes, loaded from Garden World successfully. Let's view it. Boom, there it is. All right, anything else we want to test? Oh yeah, the set dimensions, let's test that out. Yeah, it's 15.9 right now, so let's set it to something a little bit larger, like 23, or let's say 24, but it should be adjusted to, in this case now, 25. And then we'll say like 12. Once again, it should be adjusted and go one up to 13, so we're gonna count it out. Okay, so there it is. So if we count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh no. All right, I lost my place. Let's just go the other way, it's shorter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So yes, it works. The other way should work because it's exactly the same. Remember, I input, as you see, I input 12, but there is 13. I'm not sure if you recall, but if we go back into here and we go into set dimensions, we have this protection here. So if you try to input an even number, which I tried to input 2 even numbers, what's going to happen is it's going to choose this one, which is going to take that input 12 and just make it 13, and that's what happened in this case for the height. And if it happened to be odd to begin with, it'll choose this one, and I can try that and we'll see. So we'll see that the height 5, 1, 2, 3, 4, 5, it is correct, right? Because this time it chose this one and not this one. But okay, I think we're done testing. I can test it further and just really try to break it, but I think that's good enough. I don't want to make this video any longer than it already is. But if I do spot any bugs that needs to get fixed, I will update it and it will be a part of the repository. If you find any bugs, let me know and I can update it. But I think that's it. We've finally finished. Congratulations if you made it this far, by the way. We reached the end. Wow, if you're still with me, I give it to you. You definitely have some patience. Nah, I'm just joking. Thank you if you made it this far. It truly means so much to me. This is all new to me, making videos, making tutorials, trying to articulate correctly, trying to work on my communication skills. So this is like perfect for me to try to explain technical stuff to people. So this is awesome. And if you made this far, then that just means that I'm doing my job. Anyways, I want to remind you that the GitHub repository is in the link below. And if you have any questions about anything that you didn't understand, or if I made a mistake somewhere, leave it in the comments below. Also, I do have a growing community on Discord of over 100 people. So if you're interested in joining, that way we can directly connect and you can connect with other like-minded people. The link will be in the description below as well. If you want to watch my last tutorial, I'll leave a card above or you'll see it at the end of this video. It's the simple password manager. I was making the intermediate version and that was just a mess the other day. I spent hours making it and it got destroyed and I'm so sad about that. I will try to remake it at some point in the future, or I don't know, I'll just figure it out. I'm not sure. Anyways, thanks again so much. I am Ghost. I'll see you next time.